Synchronous programming is a cornerstone of modern mobile development. Without it, apps would freeze and become unresponsive, especially during tasks like network calls or heavy computations. Kotlin Coroutines offer a solution that is both powerful and easy to use, eliminating the need for complex callbacks or traditional threading. In this video, we'll dive deep into coroutines, exploring how they work, their key concepts, and practical examples that show their real-world impact. Let's start by understanding why asynchronous programming matters so much in today's app landscape. Kotlin coroutines are designed to handle asynchronous tasks efficiently. They allow developers to write code that runs concurrently without blocking the main thread. Unlike traditional threads, coroutines are lightweight and can be paused and resumed, freeing up system resources when not active. This makes them ideal for tasks like network requests, database operations, or complex calculations. By using coroutines, you can keep your app responsive and your code clean, readable, and maintainable. Coroutines are like lightweight threads that let you run long or complex tasks in the background. They're a feature in Kotlin that helps you write synchronous code in a sequential, readable style. With coroutines, you can run multiple tasks at once without heavy resource consumption. They can be paused and resumed, which means system resources are freed up when they're not actively doing something. This flexibility is what makes coroutines so valuable in modern app development. Running long tasks on the main thread in Android can cause the app to freeze, leading to a poor user experience. Coroutines solve this problem by allowing these tasks to run off the main thread while keeping the code simple and readable. This approach not only improves performance, but also makes your code easier to maintain. Coroutines are especially useful for tasks like fetching data from the internet, processing files, or handling database operations. Coroutine scope defines the lifetime of a coroutine. It controls when the coroutine starts and when it gets canceled. In Android, using the right scope is crucial to prevent memory leaks and manage the lifecycle of your coroutines. Common scopes include viewModel scope, lifecycle scope, and global scope. Each serves a specific purpose, ensuring coroutines are tied to the right part of your app's lifecycle. Dispatchers tell coroutines which thread to run on. For example, dispatchers. Main is used for UI tasks, dispatchers. I/O for background tasks like network or database work, and dispatchers. Default for CPU-intensive operations. Choosing the right dispatcher ensures your tasks run efficiently and don't block the main thread. This flexibility allows you to optimize performance and responsiveness in your app. Suspend functions are marked with the suspend keyword. They allow coroutines to pause and resume, making them ideal for long-running tasks like network calls or database operations. By using suspend functions, you can write asynchronous code that looks and behaves like synchronous code, improving readability and maintainability. A job represents a cancelable coroutine, while deferred is a subclass of job that returns a result, similar to future in other languages. Jobs help manage the lifecycle of coroutines, allowing you to cancel them when needed. Deferred objects are useful when you need to retrieve a result from a coroutine, such as fetching data from a server. Structured concurrency is a principle in Kotlin coroutines that ensures cancellation and exception handling are managed within a defined scope. This approach prevents memory leaks and makes error handling more predictable. By following structured concurrency, you can build robust and maintainable asynchronous code that automatically cleans up resources when tasks are finished or canceled. Fetching data from an API is one of the most common uses of coroutines in Android. By setting up a coroutine to make a network call, you can keep the main thread free and responsive. For example, using a suspend function to simulate a network delay, you can fetch weather data and display it once the coroutine completes. This pattern is essential for building apps that rely on real-time data. The run-blocking function creates a coroutine scope and blocks the main thread until the coroutine inside completes. While useful for testing, it should not be used in production UI code. It's a handy tool for learning and debugging, but in real apps, you'll want to use other coroutine scopes to avoid blocking the main thread. The delay function in coroutines simulates a pause without blocking the thread. This is useful for mimicking network delays or waiting for resources. Unlike thread sleep, delay allows the coroutine to suspend and frees up the thread for other tasks, improving efficiency and responsiveness. The launch function is used when you want to perform a task that doesn't need to return a result, such as updating the UI or performing a side effect. It returns a job, which represents the coroutine and can be used to manage its lifecycle, including canceling it if necessary. This is perfect for tasks that run in the background without needing to provide feedback. Here's an example of using launch to perform a long-running task in the background. By launching a coroutine in the I/O dispatcher, you can delay for a second and print a message once the task is complete. This pattern is common for tasks like loading data or updating the UI after a background operation. The async function is used when you want to perform a task that returns a result, often in parallel with other tasks. It returns a deferred object, which acts as a promise for future data. You can call await on the deferred to get the result when the task completes. This is ideal for fetching data from multiple sources at the same time and combining results. In this example, you launch a coroutine to fetch data from a server using Async. The deferred object is awaited, and the result is printed once the task completes. This pattern is useful for tasks that need to run in parallel and return a value, such as fetching multiple pieces of data for a dashboard. Suppose you're building a dashboard that needs to fetch user data and notification count at the same time. By launching two Async coroutines, you can run both tasks in parallel and await their results. This approach ensures your app remains responsive and efficient, even when handling multiple background operations. In Android, coroutines are typically launched in a specific coroutine scope to prevent memory leaks and manage the coroutine lifecycle. Common scopes include viewModel scope for view models, lifecycle scope for activities and fragments, and global scope for global tasks. Using the right scope ensures your coroutines are tied to the correct lifecycle and automatically canceled when no longer needed. ViewModel scope is used within view models to handle coroutines tied to the view model's lifecycle. It automatically cancels the coroutine if the view model is cleared, preventing memory leaks and ensuring tasks are only run when needed. This scope is perfect for tasks related to data processing or business logic in your app. Lifecycle scope is used within activities and fragments. It automatically cancels coroutines when the activity or fragment is destroyed, ensuring resources are freed and preventing leaks. This scope is ideal for tasks like fetching user profiles or updating the UI based on background data. Global scope is a global coroutine scope that lives throughout the application's lifecycle. It should be used sparingly, as it does not automatically cancel coroutines. While useful for tasks that need to persist for the entire app, it can lead to memory leaks if not managed carefully. Imagine a screen in your app where you need to fetch a user profile from an API and display it. Using lifecycle scope, you can launch a coroutine in the I/O dispatcher to fetch the data, then update the UI on the main thread. This ensures the UI remains responsive and the data fetching happens in the background. Error handling in coroutines is essential. Kotlin provides try-catch blocks to handle exceptions in coroutines, but there are also structured approaches like supervisor scope. By catching exceptions, you can ensure your app handles errors gracefully and provides feedback to the user. Here's an example of handling network errors with try-catch. By wrapping your coroutine code in a try-catch block, you can catch exceptions and print error messages. This pattern is crucial for building robust apps that handle failures gracefully. Coroutines simplify asynchronous code, making it more readable and maintainable. They improve performance by using fewer resources than traditional threads, allowing you to handle multiple tasks in parallel efficiently. Scoped lifecycle management helps prevent memory leaks by automatically canceling coroutines when they're no longer needed. Coroutines make asynchronous code look synchronous and straightforward. This readability is a major advantage, especially when maintaining large codebases. Developers can follow the flow of logic without getting lost in nested callbacks or complex threading. Unlike traditional threads, coroutines are lightweight and don't consume much memory. You can run thousands of coroutines in a single thread, making them ideal for high-performance applications. This efficiency allows you to scale your app without worrying about resource limitations. Coroutines have built-in cancellation support. Cancellation is generated automatically through the running coroutine hierarchy, making it easy to stop tasks when they're no longer needed. This feature helps prevent memory leaks and ensures your app remains efficient. Structured concurrency allows you to control and manage coroutine lifecycles, ensuring they're automatically canceled when no longer needed. This approach reduces memory leaks and makes error handling more predictable, leading to more robust and maintainable code. Many Jetpack libraries include extensions that provide full coroutine support. Some libraries also provide their own coroutine scope for structured concurrency. This integration makes it easier to build modern Android apps using coroutines for tasks like data fetching, UI updates, and background processing. Coroutines are far lighter on resources than threads. You can run thousands in a single thread, while threads are resource-intensive. Coroutines suspend without blocking the thread, freeing it for other tasks. Threads block while waiting, limiting responsiveness. Coroutines switch context faster since it's managed by the library, not the OS. Coroutines provide structured error handling with easy cancellation, making it simpler to manage errors and cleanup. Threads have limited mechanisms for managing errors and cancellations, which can lead to complex and hard-to-maintain code. Coroutines make error management predictable and efficient. Coroutines integrate well with Kotlin, reducing the complexity of asynchronous code, especially on Android. Managing multiple threads is more cumbersome and error-prone. With coroutines, you can write clean, readable code that handles concurrency with ease. Kotlin coroutines bring the power of asynchronous programming to Android with simplicity, flexibility, and performance. Whether fetching data from an API, handling complex background tasks, or updating the UI in real time, coroutines provide a cleaner and more efficient way to manage concurrent tasks. Coroutines are used in real-life scenarios like fetching data from APIs, loading user profiles, updating dashboards, and handling notifications. Their flexibility and efficiency make them the go-to solution for modern Android development. By mastering coroutines, you can build apps that are responsive, robust, and easy to maintain. The Kotlin developer community is thriving, with over 900+ Android developers joining professional groups to share knowledge and level up their careers. By connecting with others, you can learn best practices, get help with challenges, and stay updated on the latest trends in Kotlin and Android development. There are plenty of resources available for learning Kotlin coroutines, including blogs, articles, LinkedIn groups, GitHub repositories, and WhatsApp communities. By tapping into these resources, you can accelerate your learning and become a more effective Android developer. Preparing for Android interviews can be daunting, especially with technical coding questions. Understanding coroutines and their real-life applications will give you an edge. Practice coding patterns, review common interview questions, and stay confident in your knowledge of Kotlin coroutines. System design questions often focus on scalability and architecture. Understanding how coroutines fit into Android app architecture will help you answer these questions effectively. Be ready to explain how you use coroutine scopes, structured concurrency, and error handling in your designs. Medium and other platforms offer a wealth of articles on Kotlin coroutines, Android development, and system design. Reading these articles can deepen your understanding and expose you to new ideas and best practices. Stay curious and keep exploring to grow your skills. Staff picks and community recommendations highlight the most useful stories and resources for Android developers. By following these picks, you can stay informed about the latest trends, tools, and techniques in Kotlin and Android development. Choosing the right networking solution, such as Retrofit or Ktor, is important for Android development. Understanding how coroutines integrate with these libraries will help you build efficient and scalable apps. Explore guides and tutorials to learn when to use each solution. Writing clean, scalable code is essential for long-term success. Coroutines help you achieve this by simplifying asynchronous logic and reducing complexity. Follow clean code principles, use structured concurrency, and always aim for maintainable solutions. Senior programmers focus on building code that lasts. By mastering coroutines, you can write code that is robust, scalable, and easy to maintain. Always consider the lifecycle of your tasks, handle errors gracefully, and keep your codebase clean and organized. Kotlin coroutines are a game-changer for Android development. They simplify asynchronous programming, improve performance, and make code more readable and maintainable. By mastering coroutines, you'll be equipped to build responsive, efficient, and scalable apps. Keep learning, stay connected with the community, and apply these concepts to your projects for lasting success.